Hi guys, today we are going to discuss about the decision tree classifier. This is the very common interview question. So, when we are going to discuss about the decision tree classifier, there is the main two things. One is the entropy, or we can say the Gini index. Two are different things we will discuss. And another one is the information gain. So, what is the entropy? Entropy will check the node purely splitted or not. Okay. How it will check, what is the mathematical intuition behind it, I will discuss step by step. After that, one is that important another thing, that is the information gain. Information gain, it will select what type of feature we will choose and from where we'll start the splitting. So what kind of splitting and all those things? So let's start with the Python programming. See here. Here I have mentioned age equal to 14. After that, I have written age less than 15. If age less than 15, then the child will go to the school. Okay. After that, there is two things. One condition is that age greater than 15 and less than 21. If age greater than 15 and less than 21, then the child will go to the college. Otherwise, they will pass the college. So, based on these if-else condition, if we will create the tree, so what will be there? What type of tree we will create? See here. Here, what is the first condition? Age less than 15, right? If age less than 15 means there is two things, yes and no. If age less than 15, yes means she will go to college, sorry, school. If age greater than 15, that means what? If age greater than 15 means and less than 21 means, greater than 14 and less than 21 means there are two type of condition. Either they will go to college, otherwise they will complete the college. So see, this is exactly the conditional statement. Based on the conditional statement, we have created the decision tree. Based on the conditional statement, we have made one decision. Now see, consider this is the tree. Consider this is the tree. In this type of tree, there is the one concept, that is the node purely splitted or not. The node purely splitted or not. So we will check the purity. We will check the purity. How we will check? Based on that entropy and Gini index, we can check the purity. Here, one data set I have taken. This is very famous data set. So in this type of data set, it is showing that the tennis match will happen or not. Based on what? Based on the outlook. Based on the outlook. If the weather is like sunny, overcast, or rainy, based on that, uh, it will check, the decision tree will check the match will happen or not. Now, here I have taken these things from the data set. Outlook, in outlook, there is the sunny, there is the overcast, there is the rainy. And there is 9 yes. Overall, there is the 9 yes and 5 no. In sunny, there is the 2 yes and 3 no. In overcast, there is the 4 yes and 0 no. In rainy, there is the 3 yes and 2 no. See here, 4 yes and 0 no. If any value is 0, then after that we will not split the tree. So this is the leaf node, or we can say that this is the purely splitted tree. Anyone is 0. If we can write 0 yes, 5 no also, that is also we'll consider it is the purely splitted. Okay. Now, information gain we will discuss later. First of all, we are trying to focus now completely on the entropy. So this is the formula of the entropy. What is the formula? Minus P plus log to P plus minus P minus log to P minus. You can say in that way as well, minus P yes log to P yes minus P no log to P no. Okay, plus is yes, minus is no. Now again, this is the F1, feature 1. There is 6 yes, 3 no. This is the another example just. Here 3 yes, 3 no. Here 3 yes and 0 no. So now I'm trying to calculate what? I'm trying to calculate the information gain. Am I right? No. Now we are trying to calculate the entropy. How? See, this is the 3 yes and 3 no. According to the formula, minus 3 by 6 my log to 3 by 6 minus 3 by 6 log to 3 by 6. Okay. Here 3 yes and 0 no. That means again according to the formula minus 3 by 3 plus 0, that means 3 log to 3 by 3 minus 0 by total 0 plus 3, that means 3 log to 0 by 3. 0, and we got what? 0. 0 means what? Purely splitted. After that there is no splitting. So this is the formula. If you consider about this one, if you consider about this one, then it will be minus 6 by 9 log to 6 by 9 minus 3 by 9 log to 3 by 9. So in that way, we can calculate what? The entropy. Okay. So if you draw the plot, the minimum value of the entropy is the 0 and the maximum value is the 1. Okay. Now, there is another concept, that is the Gini impurity or Gini index also we can say. Gini impurity or Gini index. What is the formula? The formula is 1 minus summation of I equal to 1 P whole square. So, there is no that much of complexity. Okay, there is no that much of complexity. So, most of the case when our dataset is very big, we'll use that because the complexity is less compared to log. Now, I'm trying to calculate one value, that is the 3 yes and 3 no. How we'll calculate? So, when we are talking about Gini impurity, there is the P of square. That means P plus square plus P minus square. See, 3 by 3 is 3 no. That means 3 by 6. That means 1 by 2. So 1 by 2 whole square plus 1 by 2 whole square. That means what? 0.5. Here, if you consider about 3 is 0, no. So what is the formula? 1 minus 3 by 3 whole square plus 0. That means 0. So now, according to the graph, the Gini impurity value is the 0 to 0.5. The lowest value is 0 and highest value is the 0.5. And according to the entropy, the minimum value is the 0 and the maximum value is the 1. Okay. Now, here we have already discussed about it is purely splitted or not. Okay. Now, consider there is no one feature. There is the more than one feature. Feature 1, feature 2, feature 3. So from where we will start the splitting? From feature 2 or feature 1? How we will check that thing? Based on that information gain value, we can check from where we'll start the splitting. Okay. Now see, this is the formula. H of S, summation of B belongs to value S of B by S, H S of B. So what is the H of S? Don't confuse with the formula. This is very simple. What is the H of S? H of S is the entropy of root node. Okay. Now, consider this feature. This is the feature 1, 9 years, 5 no. This is the category 1, 6 years, 2 no. This is the category 2, 3 years, 3 no. First of all, we will calculate the entropy of root node. What is the entropy of root node? H of S. That means 9 years, 5 no. See, minus 9 by 14 log to 9 by 14 minus 5 by 14 log to 5 by 14. What is the value now? 0.94. Now we'll calculate the individually. C1 and C2. Here minus 6 by 8 log to 6 by 8 minus 2 by 8 log 2 by 8. Now again we'll calculate this one. H of S2. Minus 3 by 6 log to 3 by 6 minus 3 by 6 log to 3 by 6. Okay, that means 1. So now what we got? We got 0.4, 0.94, we got 0.81, we got 1. Now, 0.94 minus, what is the formula? 0.94 minus 8 by 14. From where we got 8 by 14? See here. 6 is 2 no, total 8. 9 is plus 5 no, total 14. So 8 by 14 into 0.81. That means H of C1. Plus 6 by 14 means 3 is 3 no and 9 is 5 no. 6 by 14 into what? Now 1. That means H of C2. Then we got what value? 0.049. Now consider there is another feature 2 and from that we got the 0.052. So what we'll consider? From where we should start the splitting? So 0.052 greater than what? 0.049. So we will start splitting from the S of F2. So this is all about the entropy, information gain and Gini index. Hope you understood the concept. Thank you. Bye.